Not sharing it. Okay. Right. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning. I bid to all of you. Thank you for joining us in this webinar. My name is Dr. Nur Atika binti Ramlan. Okay, today I'm going to talk about topics. Okay, my webinar is talk about alternative fuels and advanced vehicle. Okay, so I'm from Faculty of Engineering and Built Environment, Masa University. Okay, first of all, uh, uh, I would like to take this opportunity as a sharing moments from what I have been experienced related to this topic. Okay, so feel free to share this webinar and drops any comments if you have any inquiries related to this topic. Okay, so I'm going to share my slide now. Okay. So as you can see from this slide, okay, this is the topic today, which is the alternative fuels and advanced vehicles. Okay, so I will start with the research background. Okay, because why I choose this topic, of course, it is related to my background. Okay, for my side, I love to talk about something that I'm working with. It's something that I have knowledge about, and of course, related to my background study. For example, okay, huh, you see, so we will, okay, wait a minute. So talking about my background, okay, why I choose this topic because I've been working with alternative fuels since 2012 until 2019 during my research study or postgraduate studies. Okay, so start with the alternative fuels. Okay, for alternative fuels, I've been working firstly during my uh, master study, okay, where I did my master study at UNT under supervision of Associate Professor Dr. Abdul Adam Abdullah and my co-supervisor Professor Rizal Mamai. Okay, at this time, I was working with biodiesel from waste cooking oil and done the engine testing using various level of this type of biodiesel. Secondly, during my PhD study in UTM, University of Technology Malaysia Kuala Lumpur, I was working with another fuel called water in diesel emulsion, where I was supervised by Associate Professor Dr. Wira Jazai bin Yahya and my co-supervisor Dr. Ahmad Muslim Isnin. The same objective with master study, but this time I'm using the different fuel, but still using the method of uh, engine testing and on-road testing. So, since this webinar is mine, I'm so honored to introduce people who encourage me to do research in this area. And not to forget, both my main supervisor were under the same route, which is supervised by Professor Yuki Kidoguchi from University of Fukushima, Japan. So I'm proud to say that I was in the right track with them. And next one is about the advanced vehicle. Okay, so even though I was not working with this uh, topic directly, but during my PhD study, my lab environment at Advanced Vehicle System, ICOSA, in Malaysia, Japan International Institute of Technology, UTM. Okay, my lab environment there introduced me to this knowledge where I got to know numbers of experts and colleagues in this area. Okay, that's why I am quite confident to talk about this topic. So let's go to first subtopic, which is alternative fuel. So when we talk about alternative fuel, what is the main reason for us to find the substitute of the fuel that we have nowadays? Okay, of course, it is because of the air pollution, which caused by the bad exhaust emission from transportation and industries. Okay, for example, let's take a look at the diesel emission. Okay, as you can see in this slide, this is the chemical or theoretical chemical reaction of the diesel combustion. Okay, when the diesel fuel, which is the C12H23, react with the oxygen, okay, it will chemically will produce the carbon dioxide and water, H2O. But this is just theoretically where the complete combustion will produce CO2. Okay, however, in the actual scenario, okay, these things is not going to happen because we know that the air that we have now consists of many gases such as nitrogen and water vapor and etc. So all these gas that produced by the exhaust emission will react with this factor, okay, such as temperature, pressure, lubricating oil, and all additives which consist inside the diesel engine. Okay, it will produce the pollutant emission, okay, such as nitrogen oxide or NOx, carbon monoxide, CO, hydrocarbon, which is HC, and also particulate matter, also known as PM. And furthermore, for CO here, okay, CO or carbon monoxide is occurred by the incomplete combustion by the uh, uh, diesel combustion process. So, we can simplify all the air that we have now consists of these gases, which is we have small number of pollutant emission, which comes from the emission of the transportation and industries. Okay. So all this pollutant that I'm talking before, okay, this pollutant emission, okay, from the diesel exhaust will give bad effect, which we can categorize into human health and also to the environment. Okay, for human health, okay, we can see that the bad exhaust emission can affect to eye, nose, and throat irritation, and it also can cause the health problems such as asthma, heart problem, brain damage, bronchitis, lung cancer, and bladder cancer. And to the environment, the bad exhaust emission can also affect the air quality that we have now. And also it can cause the acid rain, climate change, global warming, and also it can reduce the soil yield and crop yields that we have. Next, this is the composition or the breakdown and carcinogenicity of diesel exhaust, okay, which uh, emits from the diesel combustion. Okay, for example, here, as you can see, the carbon dioxide, okay, emits by the diesel combustion will directly impact to the global warming. And also for the carbon monoxide, which is directly emits by the diesel combustion, can cause the biological impact to the asphyxiation. And other than that, other gases which emits by the diesel combustion, which is such as nitrogen oxide and sulfur dioxide, this is a very dangerous gases. Okay, when it reacts with the atmospheric, it will produce the nitric acid and sulfuric acid. Both nitric acid and sulfuric acid will give impact to the respiratory tract irritants and also can cause the acid rain. And also other gases which is from the hydrocarbons, aldehydes and particle phase emission components, it has its own impact towards the health and human health and also to the environment, as we can see from this table. Okay. Next, therefore, because of the bad emission by the diesel combustion, researchers had figured out many ways, okay, in order to solve the issue. And then one of the methods is by improving the fuels using the alternative fuels. And nowadays, we can see that there are many types of alternative fuels, okay, such as biodiesel, electricity, ethanol, natural gases, hydrogen, ULSD, and the latest one. So ULSD is referring to the ultra low sulfur diesel, and the other latest one is the emulsion fuel. Okay, so now we will take a look at one by one description of these alternative fuels that we have. We will start with a biodiesel. Okay, so biodiesel is a renewable alternative fuel produced from a wide range of vegetable oils and animal fats, and it goes through a process called transesterification. Okay, and pure biodiesel is compatible with most diesel engine and is commonly blended with petroleum diesel. Okay, as you can see from this slide, there are many source, okay, to produce the biodiesel. Okay, and then this is the we can categorize the feedstock into four types. Okay, which is the first one is the edible oils. So edible oils is referring to the oils that we can eat. Okay, for example, corn oil, palm oil, and sunflower oil. Other than that, is the non-edible oils. So non-edible oils is referring to the oils that we cannot eat, such as rapeseed oil or the uh, jatropha oil. Okay, this is some of the example of the oil that has been used uh, in the biodiesel production. Other than that, biodiesel feedstock also can come from the byproduct of plants and animals. Okay, so this is we can call the example such as the fats of the animal. Okay, and then the last one is the municipal and industrial waste. Okay, so it is a waste that we can get from the industry and also from the home. Okay, the home such as waste cooking oil. Okay, so of all these feedstock, okay, what we can say that the edible oils is very limited for because the feedstock is prior to the food resources. Okay, when we use edible oils, it will give an issue because some people cannot eat. We use their food to make a biodiesel, okay, but they cannot eat using the edible sources. Okay, and then for these three sources, okay, we can say that it is the promising alternative sources for biodiesel. Okay, see, but for non-edible oils, it still need quite high cost. Okay, quite a high cost because we need to plant the plant to have the biodiesel. But for byproduct of plants and animals and municipal and industrial waste, okay, we can consider it as a cheap source for the production of biodiesel. Okay, okay. Next, this is in Malaysia. Okay, we can say that palm oil is one of the main sources of the production of biodiesel. Okay, palm oil has been used to implement the use of biodiesel, where most of diesel in Malaysia contains of 5 to 10% biodiesel from our palm oil. Okay, this can be seen from this milestone, as you can see here, which produced by MalaysiaTV.com. As we can see here, from 1981 to 1984, the Malaysian Palm Oil Board MPOB began its first pilot palm biodiesel plant project. Okay, it started from 1980s. Okay, and then when in 2007, okay, the implementation of the Malaysia Biofuel Industry Act 2007 for the licensing of blending, storage, transportation, and export of palm biodiesel, including blending mandate. And then when it goes to 2011, Malaysia started to launch its first biodiesel, which is a B5 blend. So B5 here consists of, means it consists of 5% palm biodiesel plus with 90%, 95% of conventional petrol diesel. Okay, this is the meaning of B5. And then when in 2014, okay, Malaysia started to increase at the level of the biodiesel blend. Okay, it started to use the B7 blend. So B7 blend here consists of 7% of palm biodiesel plus with 93% of petrol diesel. So After 4 years, okay, in 2018, okay, Malaysia started to launch its B10 blend. So B10 blend here consists of a higher blend of palm biodiesel, okay, because we cannot start it with 100% palm biodiesel. We need to start from the very low percentage of biodiesel in our transportation in Malaysia. Yes, so Malaysia found out that B10 or 10% of palm biodiesel, okay, can work good, okay, well in our transportation, especially in diesel engine. So in 2020, it is scheduled to launch the B20 blend. So B20 is a higher level, higher percentage of biodiesel, where it consists of 20% of palm biodiesel plus with 80% petrol diesel. Okay, so why we want to use biodiesel, okay, as our alternative fuel? Because the characteristic of the biodiesel is similar to conventional diesel, but we need to start with the very low percentage first to see the how come our transport can go with this blend. Okay, and the other one, the biodiesel, it is oxygenated, which leads to more complete combustion. Okay, and it also has better lubricating properties that important to reduce the premature wearing of the engine. And also, what we want from the alternative fuel is we want to solve the problem of the air pollution. So by using the biodiesel, we can significantly reduce the hydrocarbon and sulfur oxide that we talked previously, which is very dangerous to human health and environment. And lastly, the benefits of using the biodiesel is because it is biodegradable and it also a uh, non-toxic fuel. Okay, so the second one or the second alternative fuel that I want to share is about diesel emulsion. So what is diesel emulsion? So diesel emulsion is a combination of the water, as you can see from this slide, water plus with diesel, okay, with the addition of the surfactant. Okay, as we know, okay, water and oil cannot be mixed, okay, but to produce the diesel emulsion, okay, technically we're using the surfactant. Okay, the function of the surfactant is to delay the separation of the fluids by reducing the interfacial tension between water and fuel. So we can call it as like a glue, okay, to make sure that the molecule of the water and diesel will become strong, okay, so it can mix. And other than that, of course, the mixing process needs a help by the high speed mixer to ensure that the water and diesel is mixed well, okay, until it produces the white milky color fluid like this. Okay. Next, when we talk about the emulsion, it is very familiar with micro explosion phenomena. Okay, this is the phenomena of the micro explosion in water in diesel emulsion. Okay, what is micro explosion actually? Okay, just imagine like when you put some water inside the boiling oil, okay, you will see the explosion, right? So this is almost similar or the same phenomena when the water in the diesel emulsion is started to combust inside the combustion chamber of the diesel engine. As you can see here, okay, this is the emulsified fuel, and emulsified fluid means here the water in diesel emulsion, where you can see water is located inside the oil. Okay, so encapsulated in diesel fuel here. Okay, you can see here. So at the center here is the emulsifier or the surfactant. Okay, at this moment, emulsified fuel and oxygen enter the combustion chamber. Okay, with the at the condition of 60 degrees Celsius. Okay, When it enter the combustion chamber, okay, when the fuel is superheated and expand from the temperature of 60 to 90 degrees Celsius, okay, the water droplets expand and flash ball. This is what we call as the micro expansion phenomena. Okay, and then when the temperature is getting increased, okay, the micro expansion at the temperature of 400 to 600 degrees Celsius, you can see that it explodes. Okay, when the water droplets, I mean the emulsion is droplet is uh, explode, it will increase the fuel surface area 4 times. Okay, that's why the droplets here become smaller. So when the droplets become smaller, the the surface area of the droplets will become increased. Okay, it will increase the diesel droplet density about 64 times. When the average surface is increased, it will have a contact with the air. It is easy to contact with the air, and then it easy to combust. That's why we will have the complete combustion, because all the droplets here is react with the air inside the diesel diesel combustion chamber, and then the complete combustion will produce. Okay, as you can see here, the detonation here occur at 600 to 1000 degrees Celsius, and it will increase the surface area, and higher droplet density result in a more complete burn at lower temperatures. Okay, the droplets will uh, get a complete combustion at very low temperatures inside the combustion chamber. Okay, so when the complete combustion occur, we will have more CO2. So CO, or carbon monoxide, will decrease, and it will decrease the bad emission, right? Okay, that's about the diesel emission. Now we talk about the ultra low sulfur diesel. So ultra low sulfur diesel, or ULSD, is the one of the example to improve the fuel quality. Okay, so ULSD is a diesel with a maximum sulfur content of 15 ppm. So ppm here referring to the particle per million when we of the emission lah. Okay, the US the US Environmental Protection EPA define the meaning of the ULSD here. Okay, and as already known, the existence of sulfur in diesel fuel enhance the formation of harmful uh, components such as nitrogen oxide and particulate matter. Okay, this is due to the content of the diesel, okay, which is composed of paraffin and aromatic with small amounts of organic sulfur and nitrogen compounds. Okay. In addition, US EPA also reported that about 2% of the sulfur from the diesel fuel also contributes to the production of particulate matter. Therefore, the efforts to reduce sulfur and other chemical compounds level in diesel fuel have high potential to reduce the harmful emission. Okay, nonetheless, there is a disadvantage of the application of ULSD. For instance, the refining process of removing the sulfur in ULSD results in a minor decrease in the energy content, which indirectly result in a reduced peak power and the fuel economy. So in Malaysia, as we know, the ULSD has been implemented. Okay, and we call the ULSD in Malaysia as the diesel Euro 5. If you can see in most of the petrol pump in Malaysia, we have a diesel Euro 5, and the difference between the diesel Euro 5 and the conventional diesel is about 10 cents, where the ULSD is expensive 10%, 10 cent compared to the conventional diesel. Okay. Next, the other alternative fuels is from the electricity. Okay, so this renewable energy can be used to power the electric vehicles directly from the power grid. So electric vehicles, okay, or EVs, store the electricity in an energy storage device such as a battery. And then the electricity power the vehicles wheels by means of an electric motor. Due to the current battery technology and vehicle design limitation, electrical vehicles have limited energy storage capacity and driving range. And some of the electrical vehicles will replenish the electricity with onboard chargers, and others plug into a charger located outside the vehicle. And there are currently no light-duty electric vehicles available from major auto manufacturers. Okay. Next is about the ethanol. Ethanol is also one of the potential alternative fuel, and it is using in the gasoline engine. Before that, I'm talking about the diesel engine. Now it is related to gasoline engine, and it is made from the starch crops such as corn, and also can be made from sugar beets and cane or cellulosic materials such as corn stover and wheat straw. And nearly one third of US gasoline used in conventional diesel vehicles contains ethanol in a low level blend to reduce the air pollution. So basically, in every alternative fuels, we will start with a low level first before we increase the percentage. Okay, so that's about the alternative fuels. Now we talk about the advanced vehicle. So advanced vehicle that I'm going to talk about today is about the autonomous and self-driving vehicles. Okay, so basically the autonomous is the self-driving vehicles. Okay, so autonomous vehicles, uh, it is related to the AI or the artificial intelligence. Okay, it is the key technology in the development of autonomous or self-driving vehicles. And not only is AI capable of collecting and analyzing data through sensors and cameras, but it is also capable of adapting to situations and learning through machine learning. When AI is paired with a vehicle, it allows the vehicle to become autonomous, enabling it to make its own decision without human intervention through the continuous collection and analyzing of data. So, smart cities should have highly efficient transport system that can eliminate the human error, parking rules, delays, and traffic congestion. Okay, so autonomous vehicles have gained public interest, creating new solutions in vehicle safety, better energy consumption, more efficient parking, as well as cost reduction in building new roads and infrastructures. Okay, so according to the Society of Automotive Engineers or SAE, the autonomy levels rank on a scale from 0 to 5. Okay, and 0 is no automation. Okay, but for self-driving, it starts with 1. So 1 is the low form of a driving assistance. Okay, and 5 being a complete automation, demanding whereas no monitoring and driver intervention at all. Okay, so this means the vehicle can safely drive itself under specific conditions, but the driver will need to quickly intervene when called on. This is a car that could drive itself on the highway while you watch a movie. Okay. Okay. So from this slide, as you can see, the level of the self-driving here. So level 1 here, okay, is you can see from the level 1, the driver assistant here. Okay, the automation of some small steering or acceleration tasks are performed by the car, okay, without human intervention. But everything else is still under fully human control. Okay, when we go to the level 2 or the partial automation, at this level, the automation is like advanced cruise. Okay, you know the advanced cruise control, and then the original autopilot system on some Tesla vehicles, okay, and then the car can automatically take safety actions, but the driver needs to stay alert at the wheel. Okay, when it goes to the level 3, the conditional automation, the automation here still requires a human driver, but the human is able to put some safety critical functions to the vehicle under the certain traffic or environmental condition. This poses some potential dangers as human pass the major task of driving to form the car itself. Okay, and then when we go to the level 5, okay, high automation here means that the automation of the car is that it can drive itself almost all the time without any human input. But it might be programmed not to drive in unmapped areas or during severe weather. So this is when you drive this level, you can also sleep inside the car. Okay, and then at the level 5 or the full automation here, it means that it is full automation in all conditions. Okay, so since this level don't mean much to people outside the industry, car makers don't talk about their technology in these specific terms of SAE terms. Okay, so in Malaysia, also we managed to produce our own autonomous car. Okay, and this is the one of the pioneer that I know, where I have been also work during my PhD study in uh, advanced vehicle system at MJIT UTMKL. So this is the Dr. Hairi. He is one of the uh, pioneer of the self-driving, where he positioned himself as a leader in the autonomous driving revolution. Okay, he started to have a set up the driverless electric taxi and electric shuttle solutions. Okay, so from all these topics, the alternative fuels and the advanced vehicle, maybe we can try to develop further research study that relates the combination of both topics for your future research. Okay? So I think that's all from me from now. If you have any question, maybe you can drop a comments here. Okay. So that's all. I think that's all from me. Thank you for joining us, and see you again. Take care. Thank you.